Hey guys, so yeah, so my last, so this is density. Let me just tell you which paper this is first. So yeah, so this is May June 2013, paper 31, 1 hour 15 minutes. I did the first question, and the second question I don't know why I'm not able to underline this. Let me just try again. No, it's not recognizing this as text. That's okay. Let me just, yeah. So this is recognized, being recognized as text, underlined, and then velocity is also okay. And then vectors is a mass, is a vector, energy is a vector. There's a four vectors. That's why they give you 2 marks there. Alright. The graph in figure 2.1 shows how velocity changes with time until the ball reaches its maximum height. So velocity started off with 40, ended up with 0 at approximately, let me try to zoom in. Where's my zoom? So yeah, it ends at approximately, let me try to zoom in. Yeah, approximately 4.1 seconds. Sorry, 4.1 seconds. Yes, I was right the first time. All right. Use the graph to find the time at which the ball reaches its max height. The maximum height would be, of course, what I just told you just now, 4.1 seconds. So that information is given directly to you. 4.1 seconds. The deceleration of the ball. So the deceleration of the ball is, of course, just 40 divided by 4.1, and then just 40 divided by 4.1, which will give you 9.76. So it's 9.76, just the gradient. You use the graph to find, so you have to put gradient is deceleration is equal to minus gradient is equal to minus, and in the bracket y2 minus y1 divided by x2 minus x1, and just calculate it. So but we know the answers is 9 point. I just calculated it on my calculator. Just I know the original speed is 40 meters per second divided by the time taken 4.1. Yeah, and yeah, this also gives you the gravitational field strength at that location where the experiment was done. And deceleration, don't put a negative up front because they've told you deceleration. So now which one do we use? V is equal to U plus AT. V is equal to U. The max height reached by the ball, of course, is the area below the graph. Is it the continuation? Yes. So you have to use area below the graph is just half times 40 times 4.1, which is 20 times 4.1, which is 82. So the maximum height is 82 meters. That's quite high actually. But in here, the working you put is max height is equal to area below graph is equal to half into 40 into 4.1 is equal to 82. Add a line to your graph to show how the velocity of the ball changes after it reaches its maximum height. Your line should extend to time t is equal to 6 seconds. T is equal to 6 seconds, right? To do one thing. So we know the distribution. It is 9.76 meters per second. So just multiply it by, let me just, yeah, so just multiply the deceleration, which is 9.756. If you have lost the value on the calculator, just try to calculate this again and multiply it by 6 in the bracket minus 4.1, which is 1.9, which will give you 18.54 or something. So your line must go to minus somewhere here. So it thinks of this as a check mark. Yeah, wait, let me somewhere here. Yes, it's 18.5, somewhere there. Yes, the one small square above. So let me just try to draw a line. There. Da -da 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 -dum, dum, dum, dum. there. So that must look straight with this one. If you want, you can just try to make it like black so that it looks like an exact continuation. Looks like an exact continuation, isn't it? Just that this part of the line is added by us. Alright. If you want, in the exam they will recognize this because you will most likely you will have to do this in pencil. And remember, you have to do this in pencil. On figure 2.1, add a line to the graph to show how the velocity of the ball changes after it reaches its maximum height. Yeah, so that was the question you just finished. Oh, so the next is the next question. Okay, so we will do the rest later in my next video. So guys,